probably start.
Yep. On to Ayush.
Yeah, Ayush, the floor is yours.
Yeah, perfect. Thank you so much, Lanik. Maybe, uh, yeah, the order of the sessions today will be we start with fashion, then we move on to furniture design, and then finally we look into what education possibilities lie with BeeGraphy. Uh, Divya can give a small overview about us, Odin, and then what the schedule exact timing looks like today. So if somebody is here for a particular session, please make sure to be there at that time slot. Mute Divya.
Hi everyone, I'm Divya. I'll start with our introduction. I'm Divya. We have Ayush and we have Seth is also from Codin Edu, and we'll be presenting to you three different workshops. And this is our third workshop with BeeGraphy for the Design Award. I'll just share my screen.
Divya, I don't know what's happening, but something's wrong with the mic. Sometimes I can hear you well. Sometimes it's like being like noise canceled. I don't know. Uh, are you guys like Ayush, Safis? Can you hear the same?
Yeah, it's
Yeah.
not perfect.
Okay.
Hi, is this better?
Oh,
Yeah.
yes.
Perfect.
Yeah.
Okay. So let's start. Can you guys see the screen? Yeah. So I'll start with introducing Codin Edu. We are part of a larger ecosystem. Our focus is on design innovation and making it accessible to all. So we fall in line with principles of BeeGraphy and UniXYZ. The state of design education today is not very good. So we trying to get as many people as possible introduced to newer tools and technologies available in the market, and make them upskill so that they can have a better future. We have in the past worked with universities. We have worked with other institutions as well, and this edu is part of a larger ecosystem where we have other programs like entrepreneurship and other projects. We also do consultancies. Our core principles are exploration, innovation, and upskilling, and we we are trying to retrofit the education system for the future by providing online workshops, immersive studios, and summer intern programs with multiple colleges. Um, these are some of the previous ones that we have taken offline as well as online, and then there are many others that we are trying to do as we go on in the future. These are some of them, and we are a big team. We are spread across the globe, and this is the team. Currently, today, Ayush, Stefis, and I would be taking you through the tutorials, but we have more people involved with multiple skills, um, and we are here to inspire design, like exploration, and upskill the future. These are some of the outputs we had from the previous workshops. These were related to facade design, digital fabrication, clay 3D printing, and floating communities. So some of the outputs that we previously had, and I'll just move on to today's workshop. So this is the third iteration of the workshop. Two of them were held in the last 2 months, in the second week of each month, and we'll have another one which will be next month. The first category that we'll deal with today is fashion and jewelry, and these are some of the examples that we would try to emulate in the BeeGraphy workspace. The second category we'll deal today is furniture and home furnishing. This would be closer to how do you make your furniture models or home furnishings very parametric, in the sense that you don't really have to go to the script. You can always modify everything in the configurator mode. This would make it much closer to what BIM ecosystem does. Then the third category is education. Here we'll deal with a certain aspect of education where it makes it much easier for students to understand large scale concepts which are quite difficult to understand. So this can easily help us through the platform of BeeGraphy. So I'll start with the first category that we have today, which is fashion. This category, sorry. Yeah. So this category, the intent of this particular section of the workshop, 3A, is first we'll have the workshop intent, then we'll try to understand the existing references, and then we'll try to build a design logic, and then we'll explore the design on BeeGraphy, and we'll try to import some materials, and then the challenge. So the brief of the challenge that is provided on the Uni XYZ platform is this particular section would be for fashion designers, jewelry designers, textile engineers, tech enthusiasts, and it's related to style and innovation in fashion and accessories. It wants to get out timeless aesthetics, creating wearable pieces, but with function and fashion. So at the same time, it needs to harness the capabilities of BeeGraphy as a platform. And how do you incorporate parametric design into your fashion pieces? It needs to be form, functional, and wearable. It can be influenced from the current trends of smart clothing, environmentally friendly clothing. It could be 3D printed jewelry or intricate details in your textile itself. So it could be any of these. And it can be also influenced from traditional fashion or the future. So it's a wide scope, and then it would be a good healthy playground for anyone to get involved in. So these are some of the examples we have available online. Like the piece of clothing that you see is all 3D printed. In these images, one is a carry bag, and the other one is a decorative piece over the shoulders. Then these are some of the other examples that could be done through BeeGraphy or through parametric softwares. You have parts that go around the body, neck, or the arms, and then we have large cape, and then we have dresses that flow throughout their body, but in a more organic fashion. We can also get influenced from remapping tools in BeeGraphy and can create forms which follow the contour of the body. At the same time, they become larger or smaller. They react to the contour of the body. And we can also look at jewelry through the same lens. So there are some examples of parametric jewelry. It could be earpieces, it could be necklaces, and based on tween curve functions or based on rotation and lofting. So there are multiple ways in which BeeGraphy can help you make these. The first step for fashion would, of course, be getting the sizing perfect. So we would have to go hands-on, get the widths, get the dimensions of the host, and then we can try making a form in BeeGraphy, or we can just get basic dimensions of the subject, and then we can do through that. So today what we'll try to do is we'll try to get a mix of all of these reference images and try to understand how we can do that in BeeGraphy. So I'll just jump to the BeeGraphy workspace. Also, I'll just try to remind the previous workshops are available online on the BeeGraphy's page, as you can see here, as well as there are multiple other workshops which can always help you refine your skills in this domain. So as we enter the BeeGraphy workspace, I have already created a file, but if you would want, you can always create a new file. And then it could also be shared through this window. So we have a configurator, viewer, and then we have a share mode. So you can have access to multiple parties involved in the design. So I'll just open the file. So for this particular workshop, I have a mannequin already prepared. How I did it was I imported an SVG file. I'll just show. Yeah. So I'll just explain the logic behind the mannequin. It's basically a series of lofts that you can do. It could change as per the measurements that you are taking of the subject. It could vary as it goes up. You could also incorporate the arms. And once you loft through all of these, you would be able to generate a mannequin. We can also provide you one base. And after we have generated a mannequin of a body, or it could be of a hand, for a arm, for an armlet, or we could have it for a necklace. So all of these could be generated before we start onto onto designing our wearable. So how I did this was I just got in some reference curves which were based on the sizing of different parts of the body, wherever the contour of the body was changing, and then these were put to scale and then moved to a certain height. So so for instance, I got the SVG file in a two-dimensional fashion, and then I moved it up, moved them up to their individual locations, and then I just lofted them to generate the final form. So I won't waste more time on the base of it. It would depend on your subject. I'll just go on directly to the variable part. So once we have the mannequin ready, and this mannequin is located on the grid 00 point of the BeeGraphy workspace, the first thing I will want to do is make the base curves of the dress that I'm trying to build here. So for that, we can use the curve editor tool. If I write curve editor, this is the tool that we have. Just for the explanation purpose, I'll just switch off the mannequin and I'll try to work with the curve editor tool. So as you can see, the curve editor tool is in the positive direction. This would be based on the width and height that is given here. And as we go down, we can see there are like 4 parameters here. These are basically 4 of these control points that we see. So I will also switch on the grid so that we can understand visually how big the geometry would be. So now I would have to what I want to do is develop like a outer line for the clothing, which I would then loft across so that I can develop a dress around it. So for doing that, I'll try to create that form of the clothing. So the first thing I'll do is I'll try to get a base point for the center. So base point for this particular curve editor window is somewhere here. It's a 18:9 grid, which is based on this 420:225. So if I take one of these control points to say the middle of this grid, it would come somewhere here, which is 200, 210, and 1110. So that would be my base point from where I would move this geometry and take it up to the mannequin. So I'll construct a point and I'll give it the x and y based on these dimensions. So I'll make it 210 and 110. I'll put this in the x, I'll put this in the y, and you can see it's somewhere there where this point is right now. So the next thing I would want to do is find out where my starting point is. So one of these would be my starting point, which is coming this one. So I can keep it at this point, and then I'll try to develop a geometry around. So I want it to be a closed curve. So I'll click on this tab here and I make it closed. So now I have a loop, and now I can modify these points. I would want the starting point to be at this location only. So I will double click on the curve at any point so that I can have more points in the space. So I'll just develop like a basic geometry for now. So as you can see, we have a basic geometry. It's centered around, I'll just move this a bit aside. Yeah. So you can see we have our base point and we have a curve, which is based here. Now we would want to, I'll just switch on the mannequin. So we would want this curve to be located somewhere around the somewhere around the chest area of the mannequin. So somewhere here. So I'll just move this curve first here, and then I'll move it up. So for doing that, I will just use vector to point this one. So we would want to move the geometry from the base point, which is here, to the 0, 0, 0, 0 grid point. So construct point, and this would be our second point. So we now have developed a vector which goes from here to here. Now what I will do, I'll just move this ahead. Now I will move this curve to that point, and you can see it has moved to that point. And now I'll move it up. So move again in the Z direction. So this would be around, say, 700. So I'll just write 700. Oh, so I think the scale of the curve is a bit small, so we would have to increase the scale. I'll put it as 1.5 scale. I can do that after moving it, and or we can, yeah, I think I'll do it after moving it. We would have to give it a centroid, so we can get that from the geometry itself. And I'll put it. Oh wait, I think we need to do the thing before we move it, because we already have a base point in place. And if I go back, the center point we can take from the base point we made, and the scaling I'll make as a range. So 1.5 range input. This would be scale first curve. And then I think I will move the geometry. So I'll move it ahead. Yeah. So now you can see the geometry is somewhere there. I will switch off the previous parts, and we'll just try to modify this geometry based on the outline of the body there. So we can easily move any of these curves now to fit onto the mannequin. I can introduce more points. There are two ways to introduce more points. You can either double click on one part and introduce a point. It would be visible here at the base. Or if you want, if you want to be very precise and you want to introduce a point between two of these, then you can check this is this point and this is that point, and then we can come here and we can add a new point. So then this point could be taken a bit ahead. I'll move this a bit back. And we'll do the same thing between these points. So I'll add a point here and I'll move it a bit ahead. And we'll add another point between these two, which would be here. And then this can take the shape of the back.
Divya, I can show you a trick. When you click on the points,
Yeah.
You can see the white control points. If you click on one of those, double click, it will add a point there.
Yeah. So even that way we can do that. Thanks, Lonik.
Yeah, you're welcome.
Yeah. So I mean, yeah, we just have to get the contouring of the body right, so that it can help us make some of the form. So I have a base form ready. Can make it a bit more symmetric. And the amazing thing is that you can always modify the shape later on. So I have one of the curves ready. The next curve I would want to develop is somewhere around the base. So I don't have to redo the whole thing. I will just be copying this. I will also introduce you to a node. So if I double click on one of these wires, we'll have this node popping up, and this is basically just carrying the data from here, and this could be then put into in place of directly connecting it from the main output. So if I put it here, you can see I can use it like that. uh, so now if I have to develop more curves, I can just copy this whole set multiple times. um, I will develop this. If I decrease the height to 500, you can see the curve now is at the base, and I can now reduce down the points to uh, fit to the waist. Again, I won't be very perfect here, but I think this gives you the possibilities, the scale of possibilities that we have. We can also repeat the process again for the hip area. So I'll just duplicate this by pressing Alt, and then I'll reduce down this to 300. So I think it's inside. So I will either scale this up a bit and then give it some slight variation based on the shape there. Yeah. The next thing we can do is for the lowermost part. So I'll copy one more time. And this time I will try to rotate the base. I'll take this down to 0. My mannequin actually starts at the grid point, so it's supposed to go up, but it could change as per your subject. So if I'm just doing something for the top, if I'm doing something for the lower part as well, then I'll raise the mannequin and introduce the legs as well. So in this case, I don't require. So now I have. Okay, I think this is too wide, so I'll just reduce down this a bit. Yeah. And then I'll try to rotate the bottommost curve. So for doing that, what we can do is can go to the lowermost curve. We will write rotate. Can use the rotate axis tool. You just have to provide it the curve, and then you would have to provide the centroid. So centroid can come from either the grid itself or the geometry. So centroid, put in the geometry. I'll put this into the center. Then we would have to give it an axis. So I wanted to rotate on, say, the y-axis, which is this part. So I'll just give it the y-axis, vector y, and this will plug into the vector. And then angle, we would have to convert from degree to radians. So the first thing I'll do is that, and then we can give it an angle, which would be a range input. So I'll give it, say, 0 to 90. And I can double type and write bottom curve angle. And this would go into the degrees. So then I can increase or decrease the angle. And you can see it is reflecting. Sometimes when you're increasing the angle, then you would have to modify the geometry a bit so that it fits the body properly. I'll hide the previous part. Yeah. So I will just modify this geometry a bit, increase it on that side as well as on this side. Yeah. So we have our base curves ready. Now what we would want to do is give some more character to this dress, because if we directly loft, it would look very flat. Maybe we can try to develop like a chevron pattern, and then maybe we can try to introduce graph mapper into the exercise. So I'll start with the topmost curve. Here we have, sorry, it's a bit laggy. Yeah. So we have our topmost curve here, what we can do is maybe we'll divide the curve into points and we'll take every alternate point in and out. So I will um, divide the curve by count. So I'll put in the geometry here. I will take this a bit ahead because this we can copy again and again. I will increase the count to 50. Sorry, this needs to be a range input. So I'll just write 50 range, and then I will make this as the chevron count. And I'll put this in count. You can see it has developed points for the curve. Now what I can do is I can make two lists out of the points. So I can put every alternate point in a different list. For that, we can use dispatch list, and I'll put the points in. Um, you would have to provide, so currently all the points are going in A, so we would have to provide Boolean for that. So I'll just write true ones. So Boolean is basically true and false. So it's like 0 in one list, 1 in the second list, and that pattern continues 0 and 1 continuously. So I'll put two of these. One would be false and one would be true. And if I switch off, yeah, so you can see it's 25. I would have to switch off the previous as well. Yeah, so you can see alternate points have been put in list A, and the other list would have the other points. So now what we can do is I'll just preview on one of them, and then I will try to move these points out. And for moving this point out, we would require a vector going in that direction. So maybe that vector we can achieve by the centroid of this shape. So I can just take a center point, and then from the center point, I can have a vector going to this point, and that would give us a direction. So I'll do vector 2 point again. And then I will introduce a centroid from the curve. So this is the moved curve. I can again make a node here, and I will use this node for the geometry. So this gives us a center point. Now what we can do is we can make a vector from the point 1 to the point 2, and we have the vector. So now we will just move these points and give them an amplitude. So the vector is there, but we would still have to give it an amplitude, how much distance it has to move. And I'll plug that in. I'll plug this into the vector. And I'll plug this into the geometry because that is the geometry we would want to move. Now, what we can do, we can try graph mapper here. Graph mapper can basically give us quick variations without manually moving each point in a gradient. So if okay, first thing we can do is we can try a simple one. I'll just move these points by a constant of 15. So you can see these points have been moved out. And then what we would have to do, we have the other set of points as well. These ones, and we would want to develop like a polyline going from one list to the other. So first we would have to do is weave these two lists together. So the first one I will do is this, and then the second one I will do is this. But it is asking for a number. Number is basically a Boolean. We would have to give 1 and 2. So it asks for a pattern here basically. So I will just write 1 and 2, and I can just give it both of these numbers. This is our pattern. So what it will do is it will weave from the first list first, and then it will weave from the second, and then this thing continues for the whole list. So now again we have 50 points with us that we can interpolate. So I will use a polyline, this one, and then we can plug this in. And Boolean requests you if this needs to be closed or not. So I will write a true for that. If I write true, I'll get the Boolean, and I'll put this in here. Now, if I switch off the whole of the previous part, you can see we have an interesting chevron pattern to the curve. Now, what I wanted to try with the graph mapper was that maybe we don't want this to be a constant constant distance from the base curve. Maybe we wanted to go in a gradient. So instead of this 15 here, which is a constant, we can try remapping based on the number of points we have. So if I open graph mapper, you can see there is a base where the graph would be located. So I can select multiple graphs. Maybe I'll go with a sign. And the domain for this graph is 0 to 1 and 0 to 1 and 0 to 1. So it basically graph is only this purple thing that you see here. It's only restricted to that right now. And the domain is only going from 0 here to 1, 0 here to 1. So, but we want it to reflect here, like this smooth result. We want it to reflect here. For that, we would have to give it the number of points we want to move out. So if I go back, I can first analyze what my list length would be. So if I get the input from here, I can see that my list length is 25, and I can base my graph on this list count. The next thing I would want to do is I would make a range from it, which would go from 0 to 1 only, because our domain is 0 to 1, but it would divide the domain into 25 equal partitions, so that those would then give us results based on this graph. So I'll make a range. I think it's called list sequence, and this length would go into count. Our start and end would be 0 and 1. So I would have to provide it a 1 here. And then this list would go into X. If I show you what the list has, it has 25 values ranging from 0 to 25, 0 to 24, and then it has equally divided between 0 to 24. So now we have this pattern with us, basically, and then what we can do is then remap this pattern onto our distance from the base curve. So this source is going from 0 to 1. So the remapping thing would also go from 0 to 1. The numbers that we would have to provide it as these, which is the output of the graph mapper. And the source would be 0 to 1. So we would have to again provide a domain which goes from 0 to 1, because these numbers are going from 0 to 1. And then our target domain would be how in or out we want it to go. So maybe I wanted to start from 5 millimeters outside the base curve, and then I wanted to go to, say, 30. Oh, actually, we can make these range outputs. So 5 range, say minimum distance and maximum distance. So this would go into our target. So now if I put this here instead of the number constant, you can see it has already mapped it, where it starts slowly increasing the distance as it goes till the end of the curve. So this could be an interesting twist to a simple pattern. I'll move this ahead. We can also change. We can also change the curve. So if I go for a purlin, you can see it is not as variable, but I can increase the size to increase the variation. Oh, it's too small. Yeah. Or we can go with parabola. So you can see there's like quite a lot of variation now. We can always play with how much variation we want. I don't want it to be too strong. So we can just go with a simple geometry. Yeah. So as you can see, now it looks good. We just have to copy the same pattern to all of the curves that we have. So that's why I made a node there. So I will just move this part a bit ahead along with the node. And then I will just copy this whole geometry 4 times. So I'll put this in to the node. It can be a bit laggy if there are a lot of polylines involved. Yeah, so you can see it has been replicated there. Then I'll do the same thing again for the next one and the next one. Yeah. So I'll move this here. Sorry. Yeah, once you see that hand symbol, then it has detected the node. Same with this one. Great. So now we have a variation in all of them. What we can do now is just loft all of these together. So I'll introduce a loft surface component, and then I'll also introduce a list merge. This is basically merging all of these different curves, but in a sequence. So this is our first one. So I'll start with that. I'll take this up a bit. I'll put this in. And then if I go to the list, I can add a point. I'll move this down. Plug this in. Sorry, it's a bit laggy. Sorry, I did not introduce a point, so I'll add a point, and then I will add the third one. And then same thing I'll do for the last. First add a point, and then I will add last one. So now I can put this sequential list into the loft surface component. I'll zoom in. Then I'll put this. I'll just check if the list is in a single branch. It looks like it's a single branch. So I'll plug this in. I can increase the degrees to 3. Yeah. Looks like the dress is still not it's intersecting with the mannequin, so we would have to modify one of the curves. Maybe we can try modifying the middle one a bit so that it fits. So you can clearly see the parametric nature of the script. So maybe I can increase the size a bit here as well as here. I can also add more points. I can also add more points. I can also add. It looks flat now. Yeah. So just yeah. So you can see how easily we can modify each of these curves, and we can also change the height if we want to increase or decrease the size of the dress. Maybe I want this to go a bit lower, so I can go down to the last one and change the height from 0 to -50 or more, maybe -500. So you can see we can take the dress much lower if required. Yeah. Then what we can do, we can also try importing textures to it. So for doing that, we can use an online library. So if I write texture, apply material, I'll just go material. Yeah. So geometry we want to apply is this. Now we can give it a texture string. Let me just show just a second. I'll just stop sharing. Yeah. Yeah. So for giving a texture to the dress, what we can do is we can give a string output here. So if I write text, um, uh, text input. So if I write input, we have it here, and then the string we can provide. So we can provide the string from the Polyhaven website. So if you go to Polyhaven website, you can go to their textures, which you can find polyhaven.com/textures, and then here we can go with a fabric texture. So you have multiple of these, preferably which are like slightly older. So if I go into the fabric pattern here, I can use this one. So I can just the uh, copy the texture URL, the name of the texture, and I can put it as an input file in the text input parameter, and I can put this in texture. So it can take some time, but then you can see it reflect. I would have to switch off the previous paths. I would have to decrease the metallicity to 0, roughness to maybe 1.
In fact, this
Yep.
was experimental.
Yeah.
Have you tried this particular pattern? Because not
No,
all the
not
patterns.
Yeah. No, I'll try a
Yeah,
different one. Maybe we can go with
especially,
denim. Yeah. So I'll try denim first. Yeah, you can see it has taken the denim's color and the texturing. So this can help us give a good gradient for the dress. So if now I can maybe try to develop, so in the same way that we have developed this, we can also develop a necklace for the object. But I think I will like to stop here because we have 2 more workshops, and if there are any questions related to the whole process, I'll be happy to take them.
I think you can explain about the material part, because right now it works only with Polyhaven, right? And some of the older texture, which Lanik mentioned in the Discord.
Yeah. Yeah. So currently, it is based on only the Polyhaven, but there are other things that are being tested. So what these textures, the ones that are older than 2 years, would work better. They would give the correct results. So if you go down, you can, as per your requirement, you can go and check what year it is written on the texture. So for instance, brown leather is 4 years. So I can then just select this and use it as our texture in text input.
Okay.
Yeah, so you can see it has taken the texture color. So it would work mostly with the textures that are 2 years older. Some of them are 4 years, so that would be fine. The newer ones are still in beta testing, so would be available later. Yeah.
Divya, if you rotate to the back of the model,
Yeah.
like it's flat there, or
This one,
yeah.
it's because it's because of the curve. So it can take some time getting the geometry of the mannequin right, like geometry of the curves right. So
Mhm.
each one can do it individually. So this is like the third one. So if I go and modify,
If you can modify the last one, I think the rear side of the
yeah, no, if I can just modify, say, this part, then you can see it will modify accordingly. Uh, Yeah. So I mean, the you can increase the number of these lofts to as many as possible based on wherever the geometry is changing. So I can maybe introduce one here, like one more, and then it could be more closer to the mannequin that we have. So it will make it easier for us to design. So yeah. So I mean, all of this is parametric, so it could easily be modified. Yeah. So should we take like a
5 minute break? Or 10?
2 minute, 3 minute break, and then we can start with the next.
Maybe did we have a question? We can
There's a
take it
question.
before the break.
Hello. Sorry, I have a question.
Yeah.
I was wondering why you were creating curves instead of just using a plane and make an intersection to have the, I mean, to have the outline of your model.
Yeah.
Is there no way to do that, or you have to do your curves? You have to do. I mean, you have to manipulate your own curves.
No, that's a perfect point. You can do that as well. So what you can do is you can develop like a grid and then plane, and then you can take it to the mannequin's level that you want, and then you can generate a curve there. That's perfectly
Yes.
all right. I was just trying to make people understand the curve editor tool. So
Okay.
yeah. So
Okay,
yeah,
that makes
definitely
sense,
you can
yeah.
do it that way as well.
So, Florence,
Okay,
it
thank
is
you.
required that at least at one point of time we would have to manipulate the curves to meet the actual comfort of the subject or the client. So either you can manipulate the dimension of the mannequin, the base itself, based on the size that you measured, and then doing the dress on top of it easy. The other approach, which is like a more standard approach followed in the fashion world, is that the mannequin is of a standard size and the dress on top of it is manipulated to meet the client's demand. Both of them are completely okay, which suits you better.
Yeah. Any more questions?
I have a comment.
Yeah.
When you were doing this graph mapper, you
Yeah.
were remapping numbers to change them from 0 to 1 and then remapping it again. But there was an easy way. I guess you intentionally didn't do it, but I was just curious.
Yeah. Sure.
Like you could go and change from 0 to 25 or the X and Y.
That would be manual, right?
Yeah.
It will be it is a wonderful thing
Okay.
learning. The only thing is it cannot be added with a range input. So
Okay.
it cannot be configured later. It has to be a static input. If it is very rigid, then only we can use that part.
Okay. Yeah. Got it.
It'll be static. So I just wanted to make it parametric. So whenever you can increase, I want to increase the size of these. I can easily increase, number of the chevrons. So that would be possible. If
And
it
what?
is, yeah.
Yeah. One more thing. You when you're using number constants, is it because it's easier for you can type in many ports directly, like change the default value of the port?
Where? This one?
Yeah, like if you disconnect the wire.
Yeah, I'll just do. Oh, sorry. Yeah.
You can click on the one. No, right in the port. Yeah, in the top, where the one is. Yep.
Yeah.
Over there.
I think the cursor doesn't point in the right place.
So you can change from there. In many cases, it's more convenient, unless you need a slider, of course.
Yeah.
I personally prefer to add a number constant. That way, I remember what is the input provided by me and what are the default values that exist in a node.
Okay.
But it is very useful this thing because it makes the script a lot more cleaner. Whenever there are standard values, it can be added directly, and we unnecessarily stop the process of adding another thing.
One more trick, which is in Grasshopper. I mean, you're doing it the way which is standard, like in Grasshopper, but in BeeGraphy we thought it would be easier. an easy way to disconnect a wire from the port. In fact, all wires from the port. You don't have to drag all the way. You just click the control or command in your case, since you're on a Mac device,
Yeah.
and then click on the port. You don't have to drag, so you just hold the control and disconnect.
Okay. Hold the control. And okay. It works.
Especially when the ports are far from each other, it makes it a lot
Yeah.
easier.
Yeah. That's quite handy.
There's a question from June. I mean, she, not question, but she wants you to show the material node block.
Yeah.
And how did you apply the texture? So if you can please repeat, probably,
Yeah.
what was the process of applying texture?
Sure.
Before Divya repeats it, I want to add there. So this material thing, it was a temporary solution by our developers, and it didn't mean to be there for 2 years. We did it just to test ourselves how the textures would work, but then eventually never had time to redo it, so it stayed. Hopefully by the end of the year we will make it a way easier. So what we did with textures, with the library of there is a library called Polyhaven that Divya showed.
Yeah. This
So whatever was available back then, 2 years ago in November 2022, we uploaded those textures, and if you use the name of the texture that is available as the last part of the URL of that texture in Polyhaven, it will work. But sometimes there are textures that still won't, even though they're like 3 year or 4 years old. So you would have to try whether that texture is there in our database or not. But Divya, maybe you can show it what I said and what you were actually doing.
Yeah. Yeah. It's the same thing. So once you put in the geometry to the apply material node, you can just provide it color as well. But if you want a texture image, then you can use a text input string input. So and then you can adjust the metallicness or the roughness or the opacity of the objects. I can try that as well. If I put this here, I can reduce that down. Sorry, it needs to be between 0 and 1, so 0.5 maybe. Yeah, so maybe 1. Yeah. So the next thing we would want to do is give a texture input. So if we go to the Polyhaven website, you can go to the textures. You can go to the textures, and then you'll have multiple textures based on the type. So you can,
Divya,
yeah.
you're not sharing the screen, just the tab.
Oh, just the tab. Sorry. Can you see this now?
Uh-huh.
Yeah. So we have the Polyhaven
Wow.
website, and here if you go,
You're now sharing the Polyhaven tab so they can see the URL.
sorry, I will just share the screen. Yeah. So you can go to the Polyhaven website, and then you can go to their textures part of the website, and then you can see there are 543 textures available. Then if you go to, for instance, I want fabric, I can go to fabric category, and then I can choose with the available examples. Now some of these would be quite old, but some of them would be quite new. For instance, this is 10 months old, but the particular component would work better for the ones which are 2 years older or more. So for me, like when I was trying the denim fabric, this was working. So how you would want is you will just open the textures you page, and then you can go to the top to the URL and just select the last part of the URL. And then you go back to BeeGraphy workspace, and then in the text input you can just paste the last part of the URL, and you can see it has been mapped here. Think texture mapping. Okay.
UV map.
UV mapping, yeah. So, I mean, this could be changed through UV mapping, but I think that's a longer process as well.
Explanation.
Yeah, explanation as well. So, yeah, so this is how you can basically apply textures to your objects.
Okay, thank
Yeah.
you, Divya.
Sure. Any more questions? Should we take a break, 2-3 minutes, and then we'll start with furniture?
Yeah,
Yep.
let's do a 2-minute break in case anybody wants to grab a cup of tea or
Yeah.
get rid of one. One question from me regarding the dress.
Yeah.
Like, how would one manufacture it? Like, you would have to like make it a 2D thing and then export as a curve, DXF.
Hmm. Yeah, that would be ideal. If I mean this particular design phase would be used for like presentation purpose, I guess.
Mm-hmm.
And once the presentation part is done, then they would have to think how do they manufacture this. So maybe they would have to develop like a flatter template for it. And most of the fashion industry runs on templates only, so they could easily get templates for each part of the body and then develop the template based on the chevron pattern. So I think even in that, BeeGraphy would be able to help, because once you have the template outline, then maybe they can use BeeGraphy for like parametrically modifying the shape for that particular part of the body, like that particular part of the dress. So even that is like a separate tutorial session. How do you manufacture it?
You can probably unfold the geometry and put it on fabric, cut it, and then fold it again in the same fashion.
Yeah, unfolding can sometimes have.
So I had a laser cutting machine
Yeah.
some time back. So people used to come with these handbags design,
Yeah.
So they have these shape and they will get it laser cut in the leather, small part, and then they will fold it again, pack it in the form of bag and ship it. So I think it's just unfolding the surface, the whole geometry, and then refolding it. It's
Yes, but like, I mean, what I have understood through experience is that unfold doesn't work most of the time if your geometry is too complicated. So then you would have to develop a logic behind unfolding also, like how you would want to do it.
Mhm.
Yeah. Then maybe you component first, like unitize the whole thing first, and then each component you unfold,
Yeah.
and then you put them together. So
And there is an interesting concept of packing which
yeah,
is used in Grasshopper, right? So
yeah,
that can be used to fit the all the unfolded geometries in a panel.
yeah.
I think, do we have something like packing coming up in BeeGraphy? The packing mode.
No, it wasn't in the backlog. Honestly, nobody asked for it. Maybe after this workshop, people will start asking for it. Now we
Perfect.
move on.
Yeah, let's begin. Great. I'll start sharing my screen. So we are now moving on to the second part of the workshop, which is about furnitures, predominantly interior furnitures. We already had a session uh, last time about outdoor urban furnitures. So if you want to catch up with that, it's already on the YouTube. So go ahead. And this is what our intention from interior furniture is. Interior furniture design and interior furnishing is like so particular to the context that doing a particular form or a particular design will not be highly relevant because it's your personal expression and you're allowed to do whatever you want. So with this workshop, we are trying to, let's say, exploit the another superpower from BeeGraphy, which usually is not out there in any other tool, which is the configurator part. How does it help us? Is that rather than creating one chair, parametrically designed chair, or any piece of furniture, we can create an entire family of these pieces, an entire range, so that I just define a system. I just write a methodology. And then whatever the kind of comfort I'm looking for, whatever is the ergonomics of the people is, whatever is the context around it, I can get a chair suiting that requirement immediately. So it could be like a low backrest lounge chair or a normal work thing, or it could be like a dining chair, whatever you want. You just define one process once, and then it's at a click of a button, you can get another design out of it. And how and when we can get another design, let me just give you a sneak peek what we will be able to achieve by the end of these 45 minutes. So this is, let's say, my configurator mode. I am pretty sure that you are aware of it, but if not, we will, no problem. We will go in detail in the next hour about this. So what this mode empowers us to do is that we are, as designers, are not required to share the script or the process to anyone. The first thing, that being a completely online tool, there is no requirement for anybody. Let's say if somebody is your client and you want him to give him the freedom that, okay, just change the chair the way you like it. They are not aware of how to use the software. They might not be having them. So you can just share this configurator link to them. And then all the variables can be seen on the right part of this window. And then they can easily change the parameters which they like. So for example, they like a higher handrest instead of a lower one. Let me just reload this so we can get onto it. In the meantime, we can start setting up our script to achieve that result. Pretty easy in your graph. I am pretty sure all of you have a BeeGraphy account by now. So in the editor mode, simply click on a new model, and let's say we say family of chairs. Great. We open this window. It is still loading. Yeah, here we go. We have our chair. Let's say I want a smaller handrest, and then we immediately get to see the design on the left. We have so many different parameters about aesthetics, how much meshing you want to have here, what should be the thickness of the frame you want, a sleek design or a bit bulky one, and most importantly, the ergonomics, what is the front width we want, how high we want it to be. So with this thing, we get the power that I need not to compromise with a standardized product from the market. And as a designer, that is one of our biggest intention, is to provide as much comfort to the user as possible. So based on the individual design preference, based on the individual body preferences, they can be able to configure their chair and immediately see how it looks like. So now let's get into it to start. So we want it could be, if I wanted a static chair, it could be done in a much simpler way. But with this, we are trying to parametricize everything as much as possible. So there is no static inputs. Everything comes from the user or are connected to the other parts of the design. So looking from an outside, it might look like the script is quite long, but but the intention is that by having a slightly long script, we get the freedom to have any design, any configuration out of it in the future, based on our personal needs. Perfect. So let's start by taking the basic inputs about these things, about what is the height, width, and depth of the chair. We could have done it that the front and the back width and the height is the same, but then we could not have achieved this kind of a slope, which a lot of people prefer for their comfort. If I see this chair, what are the things which comes to the mind? First thing is that it is always symmetrical, and predominantly all the chairs are symmetrical. So what we can do, we can design just a half of it and then eventually mirror it. And then we can get the entire chair. It will just help us to reduce some steps and reduce the computation time. The second thing is that there are two magic parts. The first are the surface, two-dimensional objects, which are these meshes, the first one for the back and one for seating it. And the second, the unidimensional curve or these pipes, which form the whole body of the chair. Let's start by making this piece, which predominantly imbibes, takes care of all the stuff related to the seating comfort of the people. So what is the height in the front and the back? What is the width of the chair? And also what is the depth? Let's start by creating multiple range inputs for all of them. I want first input from the user. What is the front width? And then we can define a range here, the minimum and the maximum. We do not want like a chair below 30 centimeters is definitely of no use. So let's make it 30 to 60. Anything wider than 60 centimeters which should ideally be termed as a couch. So yeah, and then we can have a step size of 2 so that we are not doing processing at every small step. So I got a node by which I can enter the front width of the chair, this width. Then I can do the same thing for the back side. And then the next thing I want is the width, the depth of the chair, how deep it is. By depth, I mean this dimension, whether it is a thin, slender, or a pretty thick one. So the depth of this chair is much lesser than the depth of this chair. So again, the kind of comfort you want to achieve. And in the depth, we can go a bit deeper as well. If somebody wants to like lie down, let's say 75, and we can start by, let's say 40 centimeter deep, the minimum. Great. And after the width and the depth, let's go to height. Front height. I can have a very low chair up to 30 centimeter, and it could be as high as, let's say half a meter, 50 centimeter. Again, I can have the same range for the back thing as well. Okay, so now I have gotten like these 5 range inputs, which the user can provide. So I think I have all the inputs required to create this piece, the one side where people actually sits. And how we can create this piece, let's just do a little sketch.
Ayush, I think you made the depth too big. I mean, the max.
Oh, yeah. It should be 75. So yeah, so let's say this is the kind of side panel we want to achieve. So what we can do, we can create these 4 points based on the width and the depth and height provided by the input, and then we can connect them by a polyline, and then in the end we can provide a fillet if we want to have a curvilinear feel to it. So let's start creating by these 4 points. The bottom left thing. First thing that as I told you before, that we want to make only half of the chair because we'll mirror the other half. So whatever the user defined input is for the width of the chair, we can just cut it by half, divide by 2, so that we are just making the let's say the right part of the chair. So I can just take a division, and then I can divide by 2. I always want it to be divided by 2, so I can just simply enter it inside inside the panel itself, rather than having any kind of user-defined input. Great, we get the half of the front width. Similarly, we can get the half of the back width. My grid is not visible. Let me just switch it on. Perfect. So let's create the bottom point here. Let's try to create this point here. So what this point should have, it should just have the front width. And for this point, it should have the back width as well as the depth of the chair. Let me start by constructing a point. It's a 0, 0 point at the moment, but where we want it to be at as the front width point, where it moves the x domain, x side. So this is perfect. This is the front bottom point. I can have the same point at the back, at the x, but it needs to move into this direction as well. So for that, we have to put the depth in the y side of the chair. Great. So we got the depth of the chair and the width of the chair on the bottom side. Now we want to have the top points as well, where people are actually sitting, the sitting height. So what we have to do, we just have to take these 2 points and move in the z direction. So I can copy the same point and then just apply the front height as the z point here. Perfect. It is pretty high. Let's get it a bit down. And for the back side of it, we can just take the point we defined here, the back point, and move it up in the z direction. Great. We get the point. Let's say if the back height reduces, this point should ideally go down. It is happening, so we are okay. It is happening as expected. The second thing which we can see here, that we are not defining like perfect rectangles here on the side. It is not, if I just give the front view of it, that it is not a rectangle, but rather we have a slightly smaller base, and then we get the panel which looks something like this. So the top 2 points are okay, but what we see, the bottom 2 points are right now at this location, the front and the back. We have to move them inwards if I want to get that effect that the base is smaller than where the people are sitting. So if we want this to be smaller than this part, we just have to shrink them in. Multiple ways to do it. Probably how we can do it is by, let's say, creating a line between them and then scaling that line from its center point, scaling it down from its center point. So let's first create a line. No, this is the top line. We want to scale our base. So we have to use these points, the front and the back. Perfect. And now I want to scale it at the midpoint of this line. So first scaling goes to geometry. And at the midpoint, we already have a component known as middle point. Let's get the curve through here. And let's get the point as the center point. Now, if I just turn out the visualization of this line, we see that the line is getting bigger because we have a scale factor of 2. It's up to you whether you want the user to have control of this factor or it is a static part in your design. For me personally, I would like the users can take care of how much scale they want the bottom place to be. So I can add another range input. And I do not want definitely it to be bigger than the top part. So my maximum range definitely is 1. And I also do not want it to be smaller than half of this, because then the chair will become unstable. So let's put 0.5 as the minimum limit for it. And then if I put it in the factor, and then we see that I have a smaller base now. I do not want to see this middle point. And what we saw some time back, that we need these 4 points, and then we are going to create a polyline and then fill it. And to get the points of this line, we can just directly use the endpoint component, and we will get these 2 points. So let me switch off the visualization here, and the visualization of the line, and now we have the 4 points. Simply, we can merge them into to create a polyline. Merge will just combine all of these individual points together into one list. So if you go to the list, visually you will see only one point to provide all your input, but there is the hidden feature. Whenever you click on any of the input node, just click on add port, and you can add as many input ports as you like. Perfect. Second point goes in, the third point, and the fourth point. Let's switch off everything. I have all the points here, and now we just need to create a polyline out of it. Polyline, we see that the order is very important when we are creating a polyline. My fourth point and the third point should ideally be reversed. So we can just do, I can select the fourth port and click move above, or I can change the input order of these things. No, I did something wrong here. These 2 points should be changed. Okay, so we got the correct order now, and I want the polyline to be closed. So I can just simply click on the Boolean and we get the closed line out of it. Great, we have the main panel where people are sitting, which is parametrically controlled. Let's say if I want the front part to be higher, this point should go up. Let's say whether it happens or not. Front height. Yes, working as expected. If I decrease the back width, this should come inside. Back width. Yeah, okay. Everything is moving and working as we intended it to be. So we got the first part for our chair frame, which was, let's say, the most important and the most tricky part. And let's apply this fillet as well to get this curvilinear feature there. Let's do fillet geometry. The curve goes in there, and I want the fillet radius to be controllable by the user as well. Range input goes here, and then it is fillet radius. What is the minimum? We can have like, okay, at least you can have minimum as 1, and maximum it can go up to 12 centimeter to 10 centimeter, the way you like it. And then let's have a step of 1 centimeter so people can change it accordingly. And I hide the chair part, and then as I am increasing the fillet, the curve is getting more prominent. Great. Let's keep it like this. So we got the first part. Now let's go on to the second part, which is, let's do this back rest thing. And as we see here, that this backrest is actually an extension of the back curve of of the panel that we already created. So the back rest is extension of this curve. So we can start by using this line here. Okay, for this line, we need this point and this point. So these two line points are responsible for this line, not exactly this point because we already scaled it. So we have like let's say a different, smaller, scaled down, moved in version of it. Let's start by creating this back panel line. And it should be this point, which is the scaled down version, and this point. And you do not see it at the moment, but I promise you there is a line. You can see it slightly in yellow. So this is the line which we just created here. Now to extend this line, what we can do in the same direction, and mind that it is not like a 2D line because we are changing all the parameters around the chair. So we can create a vector, and there is a wonderful component to do that, which is vector by 2 point. So what we have to do for this component is that I have to provide the first point and the second point, and then this component gives us what is the direction between them. So it's not necessarily be along a cardinal direction, X, Y, or Z, but a combination of them in any possibility. So we can get the points directly from above, but to keep the script a bit cleaner, we'll just do the endpoints to get the endpoints of this line. And then I start my vector from this point and end it on this point. So this blue line you see, this is the direction which this is taking. Okay, I now got the direction where I want my backrest to be, but I want to get a user input how high they want their backrest to be. So again, a range input. And let's have a minimum of 60 centimeter to 120 centimeter, and then we can have the intermediate points at every 5 centimeter for user to input their backrest height. Okay, and to get the top point of the backrest, what I can do, I can simply move this bottom point up to a height of this dimension in this direction of the vector. So we have all the input required. So let's just do that. I want to move this point in this direction. So to combine this vector with this numerical input, we can use the component which is known as amplitude. So I get the direction as the vector, which I found by using a 2-point vector, and then amplitude or the numerical side of this vector goes here from the range input, which is user defined, and I can plug in this combined thing inside this. Great, I got the height of the backrest. This is the point where the backrest should stop. If it is going up and down, as I do, yes. So everything seems to be working okay. Now, what I want to do is to have this connection till the center point to this point, from here till here. Right now, what we got is this particular point, the extreme height of the backrest. So let's just create a line from here to here. And how we can do that? We know that this plane is already existing and we want to mirror our chair along this y-axis. So I can just project this point onto this YZ plane. And then we just get that third point as well. And to project that thing, we can use is a closest point to either geometry or plane. We have a clear plane along which we want to mirror this half of the chair. So we can use that plane directly, which is the YZ plane. So let me take a YZ plane. And give me the closest point projection on that thing and this point. Great. So I got this point from the from this component, which is closest point. I already have this point, and now I just want to connect it to the chair base frame which we already created. The thing is, if I connect it to the bottommost point, there will be like a straight line going till the very bottom. But we want to have this curvilinear thing, which is like a kind of floating impression it gives. So what we can do, we can create this frame just till the midpoint of this line. We already have this line here, here. So what we can do is just let's take a middle point of this line. Yeah. So now we got these 3 points, first, second, third. Let's just connect them in a polyline, and we will have our the second element of the backrest as well. We use the same thing as before, which is list merge. Let's start with this point, which we found from the closest plane. Let's set the port. Let's use this point, and then finally the bottom. Perfect. We got all the 3 points in one list. Let's create a polyline around it. Great. And now for this particular polyline, we do not want it to be closed. We want it to be like just a backrest here. If we click on this Boolean, it will be a triangle like this. We do not want this line. So let's just not do this. And then finally, let's fillet it as well. Geometry. And for radius, we can use the same radius which we used from the user in our last step. Let's hide everything else. And now we have our second, let's say, unidimensional element as well, working fine. Third thing, let's create this handle here. Simply, what we can do, we can follow the same approach, what we followed for the backrest, that we took this line and we create a vector out of it as an extension of it. Similarly, we can apply a thing here. We can take this line, we can create a vector out of it, and then we can, let's say, kind of extend this thing. And then we can combine all of them into a polyline, and we can fillet it, and then we will be done. So I need this line here. I already have this line, which we created here. So let me just take a relay. So I can take this line elsewhere. Let's take it up. And now I want to use this line. For this, again, we need only 2 points. First point will be coming from the end point of our line. And the second one is this point exactly. Okay, I have this line. What we can do to create a vector for this line, we already have the vector from 2 point. So create this line, we can simply find the endpoints first, and then we can do vector from 2 points. First, second, we got the vector. Now to create an extension, we can take a user input, how high they want the handle to be. Let's have 10 centimeter to be minimum, maximum it could be up to 20. And then they can get any step between at like, sequence of 2 centimeters. Okay, we have the range input, and I now need to move the point. Which point I want to move? The top point by this dimension in this vector. We have all the input. I want the top point to move in a vector amplitude in this particular direction and in a height of this. And then let's combine all of them. Perfect. We have this point moving as per the vector input. So I have this point. Now let's take a similar Hendrix point for the back part. We can copy the entire thing. And then let's just add this curve here. But one thing is that we do not want the user to enter a separate value for what the height of the backrest in the handrest in the back is. So what we can do is we can just take one input and maybe just divide it, make it smaller slightly, and it's just connected to that one. We can divide it by 2 or 3. Let's check with 3 how it looks like. Okay, so this is the point after changing it. And then if I increase the height of the handrest, both of the points move simultaneously, works perfect. Let's just create a polyline now. And similar to the process we followed here, that we do not want we want to keep the curve at the bottom alive. So we will use this midpoint to start our polyline and not the extreme bottom point. To get the midpoint of the line, pretty easy. Curve middle point, we already have a curve. And we can do the same thing for our curve here as well. So now if I switch off everything, we have these 4 points. Let's just combine them together, the same methodology as before. Let's merge them and then polyline and fillet. We need not to repeat the steps over and over again. So I just copied this block from our previous part. And then let's just change the points there. Perfect. We do not want a line to be here. We can, if you like it to be. In my particular personal case, I do not want it, so I can just turn off the Boolean toggle and we are good to go. Okay, we got the handrest as well. We got the backrest. We got the main side panel. What we do not have is the plane where people are sitting. So we need to create this frame around. Similar step for creating this frame. What we can do, we can move this particular point. So we can have this line, and that can be like the starting point to create this part of this of the chair. Okay. So what we need is we need this particular point, which we want to again project it on our YZ plane, which is this point, one of these two. Yeah, this point. And then let's say closest point on plane, what plane we want to project it on, which is the YZ plane, which is this particular vertical thing. Let's take the plane in there and let's take our point. Great. So we got this point, we got this point. Now what we only need is a center point here so that we do not overshoot whenever there is a high fillet. To create this point, what we can do is we can create this line here, and then we can take the midpoint of this line. So I want to create line from these 2 points. Yeah. And then take a midpoint of it. Okay, great. So we just now need to create a similar polyline between these 3 points. First, second, and third. This is my first point. And then I can just put a relay here to get the second point, and this is the third point. We need not to manually do anything. We can copy the same block, and then we can provide the first point, the second point from the relay, and the third point. And then this we do not want, so we can remove it. And then switching off the points. Cool. We now have a frame, a boundary where we are seating as well. So we got 4 of these components. 1, 2, 3, 4. We are getting closer. One element which this chair has is this back support, which is like a counterbalance, because horizontally there are no connection here. So this helps in stabilizing the horizontal deflection. And what this element is doing is starting from the middle point of the bottom curve, which is okay. And then it is going vertically down from the midpoint here and then getting connected there. Okay, so let's get this particular point vertically down, which is this point in our script, the middle point. Remember that we will mirror everything along this axis. So yeah, this is the middle point from where we have to get the element down and then connecting it somewhere here. How we can get this point we already used, not this one, but this one. Okay, so we already have this point. Now let's just move it vertically down, which is move when we know that we have to go like in a perfect axis in a cardinal direction. So we can use a unit vector, which is z. We can go, so we do not have to create a 2-point vector based on existing line. This is the geometry which we want to go down to, and how down we want it to be. We can just like define a number that just make it 20 centimeters or 30 centimeters higher from the ground. So let's say, and higher from the ground, what is the total height? This is the height. This is the height of the backrest which users already entered. So if I just go there, what is happening? This was the height of the user that they already entered. We want our point to be somewhere here. And let's say this is 20 centimeter. So to get this height, we can just subtract the 20 centimeter or 25 centimeter from the user given backrest height. So yeah, let's use the subtraction. There should be the backrest height, which is this. Let me rename it so that do not forget it. From the backrest height, please subtract 25 centimeter. So I'm creating a number constant. It is not a user defined input. So I'm not using a range input there. And then this is the number. Strange thing, I see that I wanted the point to come down, but it went up. So what we have to do, we have to just use a negative or an opposite component to change the direction of it. So I change the number to a negative number. And now we see that the point is coming down. I got this point. Now where I have to merge the center point of this bottom thing. We already got this point. Remember when we were scaling down in the very first step, we use the center point of this line. So we should have it somewhere. Then this is the point where we were scaling. So yeah, this should be the middle point along with we scaled it. Following our same routine, let's merge all of these points together. The first point is this one, which is this point, the one on the top. The second point is this one, which we got after moving it vertically down. And our final third point is the center point, which we just found out. Great. We can switch off the visualization and then see how it looks. Yes, it is looking as in the design. Let's do one thing. Let's mirror them and then see whether the whole chair is coming as expected or not. So let me take a merge component to have all our different parts into a single list. We have a total of 5 parts, so let me add more ports. And the final one. It is always preferable and suggested to flatten if there might be data coming in different streams and different branches. So just flatten it once to be safe. And then let's mirror it. And when we mirror it, yes, we get the chair skeleton perfectly all right as we wanted it to be. So, okay, great. This part is working. I can disable all of them or I can keep them. It's okay. So we have the chair skeleton done. We just have to do a piping on it, which is an easy part. And then now let's get the two-dimensional elements, which is this surface where people are sitting and the back surface. What is this seating surface doing? The seating surface is it is not covering the entire thing. We have a slight gap on both front and the back part. So only the linear element, no curved part, but only the linear element from this thing or from this chair boundary is being used. So what we can do is we can use this polyline curve and then we can extract only this particular length from it. Let me show you how it can be done. So this one was this element, perfect. Let's explode it. So what explosion does, it gives us individual curves and points rather than a complete thing together. And we want one particular curve, which is this one. So we can use a list operation, which is known as list item, which gives one item from the list. So from all the curves out there, I can hide this I need only one item. And you see, when you just select the component, one of the curve will be highlighted in yellow. I am not sure whether you can see it clearly on the stream or not, but at the moment, the bottom curve is highlighted in yellow. So let me just change the index number, and then it is 4 now, and then find the correct curve. Other possibility to do it is by using a simple range, and then or hiding the other parts would be helpful as well. Yeah, this is just to show you what is happening when I'm changing the number. If I do 2, no. Yes, perfect. This is the line we wanted. And then to create a surface, what we can do, we can again mirror it along this YZ axis, and then we can loft these two curves together into a surface. Mirror. And then we got the 2 line. Why we are not simply extruding it? Because it is not a two-dimensional planar. It is not a two-dimensional planar surface parallel to the cardinal dimensions. There are changes in the back height and the front height, back width, and the front width, so it is more like a trapezium. And it is not parallel to the XY plane. It could be moving up and down. So by following this method, we are robust, and doesn't matter what the user input, we will always be able to get the correct surface out. So let's just add these two lines there. The first line is this one, and the second line is this one. And we got the surface out. So the surface is perfectly fine. We are now just want this pattern onto it. And if we were using, if we were on Grasshopper at this moment, we will be required to use a plugin like a Lunchbox to do this. But fortunately, in BeeGraphy, we already have that capability built in. And then if you go in your tool set, and if you move around somewhere, you will find hexagonal mesh, which is exactly here, hexagonal paneling. So we need to do a paneling on this particular surface in a hexagonal way. Great. Now what we can do, we have these hexagonal panels. We can just offset them inside and then create surface between them. But I want this panelization is too big for me. If a child is sitting there, it might fall down in between. So I want to parametrically control how big the meshing is. So let us take an input from our user, how big they want the mesh opening to be. So let's take a range input. Let's say 1 centimeter will be too small. So let's say 2 centimeter to 3 centimeter, or up to 4 centimeter, and they have a step size of 0.5 centimeter. What I will do, I will just measure the length of this side and divide by this. So we get the number of U or V, or the number of panels in this direction. Similarly, we can just do we find the length of this one, and then we divide by this, and then we have the other thing. So let's take the length of this side first. Curve length, we already have our curve. And then we can simply divide them. And then we can have, but one thing which we have to take care here, the number coming out here is a natural number. If you just see here, it is 26.07. But when we are defining U and V, we have to provide an absolute number. So we have to just, let's say, do a round off so that everything is clean and the input for our paneling tool is well defined. Great. So this site is done. We never created this line. We just lofted this line with this line, so we cannot directly measure the length of this side. So what we can do, we can use this point, which where component by which we want to identify the proximity of the things. Yeah, so curve proximity. So what this component does is if there are multiple curves defined, it tells us what is the closest proximity between them. So this is our indirect way of identifying that dimension. So let us add both of these curves here. The first curve, the second curve, and what we get out as a number is the distance between them. Let me just reload it. If there are any errors, because it is a web-based thing, just reload it and 90% of your problems will be solved as we see. Okay. Again, I just need to divide and round off the number so I can copy the two nodes, divide the top number here. We are already rounding it off and then add it to the V side. Our mesh should be homogeneous now. Perfect. But it is extremely dense. So I'm going to increase the dimension for now. And then we can come back later and then make it thinner. Okay. So we got the mesh. And what we can do now is we got, like, let's say our individual cells like this. We can offset these cells inside. And then we can put a surface between them. So we get like a slightly smaller cavity. What we are going to do, we got the hexagonal panels main, and then we are going to offset the curves. We want to offset the hexagons. And how much? We enter it directly here. That's a 0.6. But what is happening? They are going in the other direction. They're overlapping with one another. I want to offset them inside. So I will just put a negative in front of it. And it looks good. Perfect. Now we can just loft our inner hexagon with our outer hexagon, and then we get a surface in between them. For loft, we need to provide two surfaces. Here we are working with a large data set, so we can just draft them so that all of the offsetting, all of the lofting can be done in a single step. Perfect. I want the first curve and the second curve. Lofting happened. Great, we got the mesh as well. If I just hide them, awesome. So we got the base surface in. If I switch on this mirrored geometry and this geometry, we have the front sitting base as well. We just need to create the back surface. The process is extremely similar. All of the meshing remains the same. We just now need, instead of a line here, we just change the input line from our back. So what we can do, we can take our back line, and then again, we can similarly, this is our back line. Great. We can similarly explode the geometry and list item to get the correct curve, and then we can just input it there. We exploded the geometry. Now list item. Great. So this is our item. We just now need to apply it on this thing. Let me create a node here, and then we can copy the entire thing. So we are going to connect it here before the explode, and then we need the index to be 2 as we identified. Let's just connect the base curve, and our index is going to be 2. And as soon as we did that, we got our back meshing done as well. We are almost there. We just need a frame around our unidimensional elements, which is, let's say, the easiest part of the entire evening. We can use a component which is pipe. And then we have to define a radius, which we want to take it from user. So it needs to be a range input. And it needs to be a radius. So let's say I can have a radius of minimum 1 centimeter up to, let's say, 2 or 3 centimeter. Let's go with 2. I want to start with a radius of 1.2 centimeter. I put the radius here. And then in piping, I need to put both the left side and the right half. So I can merge them together into a single list. And then we can just provide this curve as input to our chair. And we have all the piping being done as well. If we just turn off the visualization of the curves, we will not see the red lines. And then simply you can apply all the different kind of materials. We already saw in detail about material application with Divya. So I need not to go in detail for that. And then let's try to see whether it is working parametrically or not. First thing I want to change is I want to increase the backrest height. We have our backrest height somewhere. Let's increase it. Let's see what happens. It took a couple of seconds and perfect. I have a chair which has a much higher backrest. I want the chair to be deeper. What we can do is we can increase the depth of the chair from 60 to, let's say, 70 centimeters. It will take 4 or 5 minutes, but you see the power that we just created a system out, and doesn't matter which kind of chair we want, what kind of function we want, everything can be achieved directly. Cool. Any questions you guys have now about this before we move to the next part?
You are on mute, Ranik.
Yeah, thanks, Ayush. I actually had a comment, but I forgot. Also, probably I was revealing some tips and tricks in BeeGraphy. I put a note. I had to leave my notes in another room. My kids started to make noise, and I left to another room.
Okay, then let's take a couple of minutes break and move to the third part after that.
Sure.
The chair itself, would it be rigid enough? Like,
Yeah. The main intention of adding the back support was to make it, to get the visual elements out and then still make it rigid to sustain.
I'm not an engineer, but like if I would be thinking of the rigidity or trying to make it rigid, I would just add like perpendicular lines at the bottom plane.
Yeah. The whole point of this parametric modeling was to get rid of the conventional way of doing it, to find another way.
Mhm.
But yeah, that can definitely be added. It also depends on a lot on the material strength, whether I'm making a chair out of bamboo or it is a metal-based thing. So for metal, I checked it and then it works fine
Mhm.
with.
Yeah, that's a good approach.
Learning just off topic, what is dynamic grouping, that the new feature we have launched?
Oh, probably would have to do some demoing of its applications. It's something that didn't. I wasn't the public starter. Let's go it this way. The reason it appeared, I think there was some use case that maybe one of the users had that they requested, and the developers decided to do it. Like just to just some give some basic explanation. It allows to have multiple inputs with how do I explain it? You can keep one input in multiple tabs,
Mhm.
and then it will be multiplied by the number of tabs. But I don't know about the use cases, like when that would be easier than just copy pasting the inputs.
So you can apply a value to multiple nodes at the same time, like multiple counter or multiple input nodes that are there. So you can apply
Yeah,
same
but have
value.
on the no, it won't be same actually. It will be different. You will see one range input or one text input,
Mhm.
but in reality it won't be one. It will just have like it will be a group with several tabs,
Mhm.
and then when you change tabs, it will be different values for each tab. But visually, it will be just one input, so it will keep it cleaner in some way. But then also you will not be able to see all the inputs at once, so you will have to physically change the tabs in the group
Mhm.
to be able to see that.
Ah, got it.
Like imagine you have some geometry and then you have text on top, in the middle, and at the bottom. You can have one text input, but then 3 points where the text is located. So you type the text for the first one, then change the tab, type the text for the second one, change the tab, type the text for the third one, and then the text will appear while you're typing. And then you can remove one by one, but you will not be able to see them, to see all the 3 inputs at once.
It is basically, in short, we are trying to create, sort of group of different values
Yeah.
in the input node. Yeah. So
Mhm.
kind of different scenarios that are there and the different possibilities that can come
Yeah.
under different tab. I just opened that, I'm in the small video that was there and was just trying to understand what it is.
Maybe we should
Sure,
create some use case. It's actually not finished, not fully finished, the dynamic grouping part.
Mhm.
I think the guys plan to finish it next week. Or maybe it's finished, but will be deployed next week.
Got it.
So the next, we will have questions, I guess. So the next part of our tutorial or workshop would be for education.
The education part.
And
Am
I
I
think
audible?
Yeah.
yeah, we
Okay.
can hear you. I think it's very good in terms of understanding the rotation of Earth around the sun, right?
Yeah.
The solar
Yes.
path.
Okay.
This
Cool.
will be like basic, right? We will not go all of the planets and
No.
no moon.
That'll take a lot of time. Let's see. I'll try to keep it a bit more simple because there's a lot of vectors coming into play. So let's see. Cool. So I think we can start. I'll share the screen. Yep. Okay.
Yeah, we can see it.
Cool. So hello everyone. My name is Safis and welcome to the third part of our workshop. Today's focus would be education. So we'll explore how BeeGraphy can be a powerful tool to explore some interesting concepts and also help us visualize some scenarios that will help in learning some concepts better. Now, if we look at the challenges that have been put up as part of the competition, so this falls under category 7. And it's about exploring and expanding computational design tools to provide a more immersive and hands-on learning experience. And therefore, for this workshop, we'll develop something similar to the challenge, but a bit more of basic level than what you see on the image. We'll try to learn the concepts and then see where we can go from there and detail out as we move further. Sorry about the background. Some cop chase going on. Cool. So the goal of the workshop is to explore the concept of sun position based on different geolocations and also create sun paths for these locations based on some of those principles using BeeGraphy. There are tools available in the industry, but we're exploring how this can be done through BeeGraphy. Now we have to follow a couple of steps as we move along with the script. So setting up positions of the sun, earth, and then we figure out how the time of the day and also day of a year. We'll then go into latitudes, longitudes, how to set that up, and then use geolocations to select any place of your liking, and then see how the sun path works for that location. We'll develop how we'll see how a basic sun path diagram functions and set that up. Also, we'll look into something called text tags, and we label those locations using those methods and then export it to the configurator tool that will help us then play around with all these parameters. Now, to give a summary, this is the kind of the basic setup. So we have the sun, we'll figure out the positions, how the sun path is aligned. For this, we need to understand radius of the sun, radius of Earth, the distance between them so that we can figure out the orbit properly. We'll then move into latitudes and longitudes. We'll be working with the base as the meridian and the equator, 0, 0, as the base and set up all these latitude, longitudes. That helps us identify the coordinates so that we can develop something more similar. And I think in terms of textures, we're not there yet, but discussing with learning, I think if we can set this up later on where we can import a bit more 3D textures, that'll be cool to then map it on the globe that we develop to get a more realistic experience of Earth and Sun and other planets. For each location that we select on Earth, we'll develop this model of sun path. This is a typical sun path diagram that we use for mostly architectural purposes, for building orientation, facade detailing, etc. So that will be quite handy to see how this can be developed on BeeGraphy. We'll also try to set up some tags like this. So if you have locations, this will help us position ourselves on the planet for the time being, so that we understand in terms of references where our located sun path kind of travels. And then the configurator mode where we can, so these are some of the parameters that we have: day of the year, time of the day. We can, of course, adjust the base dimensions for the purpose of workshop and to see planets a bit closer. We've given a bit more hypothetical dimensions as scale, because I'll show if you take the exact numbers, it's massive, it's too far away, we won't be able to work. But we will give those options as one end of the range, just to visualize. And yes, and then we can, I think we'll take a place from the chat, and then we can put those coordinates and try to set up the sun path for that location. So yes, so with that, we can quickly jump to the script. And before that, just show what we are going to set up. And I'm sure we'll have to move quickly. I'm aware of the time. So these are the things we have: our basic celestial bodies, Earth, Sun, and the orbit. We have the equator marked up. We have the location and the sun path assigned on it. We have a small building, and we can see where the sun is. We have reference locations and also a demarcation of which part of the Earth is now facing daytime and the other as night. So we can add that information as well. So yes, so this is the basic setup. And I'll quickly show the script I will have to develop. Ignore this part. This is not as complex as you see it. We will be starting from here, develop the basic geometries, sun, orbit, Earth, and then we will look into the positioning. So this is where we figure out the revolution of Earth and also the rotation. What I forgot to mention was that since we are doing a basic model, we will be taking some assumptions. For example, the axis of Earth is not exactly vertical, so there is an axis tilt. We are ignoring it for easier calculation of the geometry. And also we're considering the geometries as absolute primitive geometries, like planets, and planets are perfect sphere, orbits are perfect circular. Also the position of the sun is exactly in the center, which if you look at the exact model, it's slightly shifted and elliptical in nature. So yes, so in this part we'll look at revolution and rotation. Once that is set up, we could find demarcation of the daylight area. So this is being projected from sun, and we find that line. We'll also demarcate the equator, which is a fairly simpler procedure. Then we come to a slightly more challenging part of the exercise, which is to figure out latitudes and longitudes. The longitudes is fairly simple because it's more on the vertical. We just need to get a vertical strip and then we rotate it. While the latitudes would be a bit more complicated. I'll explain it through some sketches as we move closer to the script, and then once that is done, we'll be doing a bit of location naming. That's also a simple script. The important thing is this can be done for your any other exercise as well, for labeling any diagrams or any particular element of your form exploration. Once that is done, we'll set up a base plot, which is this circular base. We'll add a small block to it, and then we'll draw the sun path. This might take a bit of time, but I'm sure once we have gone through, we'll understand how that can also be dealt with quite easily. And that's the challenge. So let me quickly set up a new canvas, and then we can go one by one. As we discussed earlier, we'll be setting up with an axis. So center point of our model, this is where the sun would be. We construct a point with location 0, 0. Quite simple. What we need is a sphere, which would be our sun, and we connect it to the origin. Just a second. We reload the page. Okay. Yes, okay, so now it's ready. So we have a point, and we need to bring the sun. Now we have to give the radius, so this part is important. Now we can give it a range. For our, how do you say, easy modeling, we'll give a hypothetical radius of 500. But we could also create a range with the actual numbers, right? So, so it's somewhere around 696,340 kilometers. I think that's what the radius of the sun is. So that gives us a range. Cool. We're doing this so that if we want to learn and easily make changes, we go with the simpler one. Otherwise, we make the expandable. Well, let's go with this. So quickly, once we've set up the sun, what we'll do is we'll create an orbit around. So for that, we'll create a circle. And the origin is the same as the center. And the radius is the orbit thing. Again, let me label this quickly so that this is not confusing. Sun radius. And then we'll give a range. Since it's slightly larger, so we can give 3000, and then so this is the orbit radius connected to the radius. Good. So you have the radius. Now what we need to do is to find the, so every circle has a starting and ending, even though it's a continuous loop. And to get that point, what we can normally do is to explode that circle. That's kind of the approach that we can take in order to identify where the circle is starting from. Once you explode, give to the curve, and that gives you the point. So this gives you the point where the circle starts. This is important because when you're starting all these, your rotations and everything, you need a reference point, and that's why we need to take this approach. And once we have this, we're creating now our planet Earth. Again, a sphere. Um, yes. And all we have to do is give the radius. We can give a range. Again, we can start with 500. Then we give the radius of Earth as a maximum, somewhere around 6,071. We rename it to Earth radius. Okay. So we have our basic geometry setup. And I think before we go further, let's clean it up or even give quick material to these objects. So you can apply material, connect the geometry, we connect sun, we can give orange, bright. I think that should work. And we can hide the initial geometry. Give roughness 0, so it's a bit more shiny. Do the same for Earth as well. Let's copy another. For this one, let's give it remote look. And then we hide these geometries. Cool. So step 1 is complete. This is setting up the basic geometry. Yeah, ignore this one. As we move closer, it comes more clearer. Now, once these are set up, our next step is to create rotation and revolution of Earth. Okay, so this is where we'll introduce a concept. So open something like this. Okay, so we have sun, and then we have the orbit, and we have the point, right? So this is where everything starts. And now we have Earth. Now there are two things to think about. One is the overall rotation, revolution of Earth around sun, and then you have an axial rotation, right? Now this is what decides which day of the year is, and this rotation is what decides the time of the day. Now we have to run these in parallel. And this is where the concept of remapping comes. So you have a component called remap numbers. And the reason why we do it is we need to align data with different units. So what we're doing is we have one revolution. Let's say it starts from this being 0, and then you end up at 1 year. And we have another unit where it's 0 days. Then you have 365 days, right? This is what makes a year. This is 1 year. And if you think about 1 day, it's again 0. So then you have 24 hours, because we will be giving the time in hours, and then we'll be giving days. So in order to match all of these, this is why we do the remapping of these data. Okay, so now let's get back to the script and start adding these changes. Now we want to do a rotation or revolution around the sun. So let's do revolution first. And for that, what we need to do is we have the rotate command. So this one helps you rotate around a particular axis. So the geometry we want to rotate is, of course, Earth, right? And then it's asking for angle, but it's in radius. So we can get degree to radius, because the data that we would be providing would be in degrees. Okay. Now, the reason why we remap is also another additional data that comes in, because when we are rotating, we have degree 0 to 360. Right now, we are going to match the 0 to 360 degrees with 0 to 365 days and also 0 to 24 hours. And this is what we're going to do with remapping. Component remap numbers. We connect the number, which will be our degree value. And then what we do is we need to give in the numbers. So let's create a range, and that range will be from 0 to 360. And then this we'll call it, because we're doing rotation around the sun, we'll be doing day of the year, connected to the number source. And then what we have to remap is, so we have the source 0, 365, 365, yes, 365, and the target is 0 and 360, because we want to get the data out within this range. So here someone's inputting 0 to 365, and that then calculates it in terms of 0 and 360 range and gives in as the end. So now if you keep adding your rotation, as the number of days passes by, the rotation is rotated. And then what we can do is to change material from this and onto this, right? Because this is the final updated geometry. Now we have one more that we need to figure out. It's time of the day. So if you have seen, we didn't update this, but it takes anyway by default. The center point or the axis is important. So here the axis is the point that we gave in the starting, which is the center of the sun. We've given that. And for the next rotation, feel just a second. Rotate. Yep, connect to this. Same process, but in this case, the rotation is happening not from the overall center, but the center of the earth. So we need to extract the center point. So for that, we can use centroid command, connect the geometry, and then you get the center. Connect it to the center. Now we need to input the angle. So it's the same process. We can just copy, paste it. But this we'll call it time of the day. And then we have to change the range, because this will be from it's a bit 24 hours. To add a bit more resolution, I think we can just add more steps. So we get more decimals. For the days, I think it's okay. That's enough number. We'll have to change the range here. The target is 360. In this case, here is 24. We have the angle. Give it here. So this is the rotation of it. And then we can update this again. Good. So we have these two parameters which we can group and label something like Earth's position. These could be grouped into the base dimensions, right? Because when we're going to this mode, this will come nicely and grouped up if you do it like this. Cool. So we've done those two tasks. Now the next thing we'll need to do is to figure out which part of Earth is facing daylight and which is the dark side. So for that, what we need is we need that ring. We need to generate that ring. So one way to do it is, so we have Earth, we have Sun, we have the center points. Now we need a ring that demarcates this line, which is perpendicular. Right? So what we can do is to maybe create a vector along these 2 points. So you need 2 points and create a vector. So it's a 2-point vector. And then we need to select a plane which has this as a vector. So therefore we get a perpendicular plane. And then we can slice the planet with this plane and then extract the circles. We have a few components that can help us do it. So first we need to set the vector. We have vector 2 point. So the first point is the center of Earth, which is here. And the second point is center of the Sun, which is the main point. So now we have the vector. Now what we need to create a plane by normal. So this is the one. So if you give a vector and also the origin. So the origin is the center point of the planet. So this is where we want the vector. So we have the origin and the vector there. So now we have those two basic tools set up. Now I'll introduce a component here. So if you go into tools, we have under the intersections solid plane. So you're basically slicing a solid. In our case, is the planet. And then we're using this plane. So that gives us the ring. So now, whichever day of the year you select, that ring will follow this word, this vector. So that is nicely set up. Now our next task was to create the equator as well. So we have this ring, and then the equator gives us a good form of reference. So this one is ready. Let's just group this and call it day and night. Creating equator is quite simple. All we need to create is just a circle with the same radius of Earth. So we create a circle. The origin is the center of Earth, and the radius is the same radius of Earth. And now we have the equator as well. Those basic things are set up. Now next, we are moving into slightly trickier bit, which is the latitudes and longitudes. So here we've seen this is a thing. So we need to divide Earth into vertical strips, 180, 180, so 360 of them, and then you have to cut, slice them top to bottom, positive and negative. So these are also important. Our reference point is 0, center, and then whatever's above is positive, whatever's below is negative. Same goes here. We take the prime meridian as the base, and then we go to the right is positive, left is negative. And the way we had done for the orbit, we do a similar strategy is to deconstruct our Earth. So whenever you deconstruct a circle, you get a point, right? And so when you deconstruct a sphere, you get a ring, which was used to make the sphere. And that will be the starting point, which would be R00. So what we'll need to do is to deconstruct the solid. So in our case, it's Earth. And then focus on this. Cool. So this is the line that we got when we deconstructed a sphere. So you see, this is a curve. And that will use it as our 0, 0. So the same this line, the prime meridian. We'll use that as a reference, and then now we'll start rotating. We need 180 from here to this side, and then we need another 180 from here to the center. So for that, what we'll do is we'll keep the center as the axis, vertical axis, and then we'll rotate it. Similar to the previous method. geometry is just curve. And the center point is center of Earth. And the vector is the axis. So in our case, by default, it's Z axis, which is a vertical axis. So it's okay. Now what we need to add is the angle. Now this one, we need to create a range. So our angle is the longitude. So longitude starts from minus 180 to plus 180. So that's the range that will create here, minus 180 to 180. Okay, maybe set it up this way, and then we change it. Make this minus 180. Yeah. Then maybe add a bit more resolution. So if you look at coordinates, you get 4 digits, right, for most coordinates. And I think let's give 4 digits so that's accurate. So when you can directly copy and paste those coordinates. Now this will be our longitudes. Again, the data that we are providing is in degrees, and what it has is in radius. We need degrees to radian. Let's group it. We call this is our longitude. That part is sorted. However, the latitude's a bit trickier. So I'll just do a sketch. So we have the equator as well, and we have the center, right? Now imagine this is the prime meridian that we had. 0. This is plus 90. This is minus 90. And this is 0. So if we have a vector, this is how it is. And then we keep rotating it. Now in this case, our axis is not Z axis anymore because we're not rotating this way. So we can take any of the X. We could take the X axis or even Y axis, and then we use this as the Y axis. And then what we'll do is we'll rotate Y axis along X. Okay. And if we rotate it 90 degrees, we reach here. And then if we rotate it this way, we reach here. Right. So this is what we'll have to quickly set up for the latitude. Concept is slightly different, but it's building on to the previous one. So what we have is we need a vector which is, let's say, X vector. We need a vector rotate component. So this is asking how we want that vector to be rotated. We say X. Now the angle that we need to provide, which is similar to longitude, So we can just copy and paste, give it here. But there's a slight difference. In this case, we have it's from -90 to +90. This is our latitude. Cool. And the center point is again the center of Earth. To hide some of these. Cool. So what we're doing is we're now setting up these vectors. We haven't created a line yet. Now, once you have this line, suppose we have, this is both 23, and we have rotated it 23 degrees, and then we have it like this. Right? So these are just vectors, but what we need is a point. We need to get a geometry there. So either a line, surface, or a curve, because right now it's all vectors. So what we'll do is we'll create a line starting from this point along this vector that we have just created. And then we could find the intersection of this line on the surface. So that way we can get this point. Cool. So let's do that. As I mentioned earlier, so here it's set. So we are rotating it not along Z, we'll rotate it along X and Y. So now we have the vector. I want to just show it, so maybe you can. Okay, so we have the center point. We'll create a line. So if you have one point and one vector, you can create line using line STL. STL. Point is a center point, so let's connect that. And then the vector is the vector that we had just created. Now the length. How much would the length be? It's the same as the radius of Earth. So we connect that to the radius info that we had. So we had provided radius here. So if we can create a relay, we can take it from here. Okay, so that's the line that we have. And of course, it's at 0. So if we adjust it. So what you can notice is when it's negative, it's going up. And when it's positive, it's going down. However, we want it the opposite. So we want it negative and it goes up, and positive. What we need to add is we need the data to be inverted. So we add an opposite component to it. So now if you hit 90, you have it here. If you hit -90, it's there. Okay, so in terms of latitudes, we have this particular vector. Now, as I mentioned earlier, we need to find the intersection of this line. Only then we get the point, because what we are looking for is that geolocated point on the planet. For this, we can use another intersection tool, which is intersect surface curve. We have a curve, but now what we need is a surface. So you remember we had deconstructed the planet, which is the solid. But when we deconstructed, what we get is curves, surfaces, and points. And we can add that surface here. And that gives the exact point where it intersects. Cool. I can add a bit of opacity to this. And then make this visible so that we see. Okay. Now this is the tricky part. So we have a lot of these longitude lines. And if we set, so now our point is here. So we've given the latitude value, which is, let's say, 23.xxx. If we give 47 as our longitude, and that's this curve, how would we find the intersection of these 2 points? Because the 2 coordinates should, in the end, identify one particular point. So what we do is we need to create a surface around this point. Okay, and then when this intersects that surface, we select this point. Now that point will be on the same latitude as well as on the same longitude. Now that way we find the common intersection. And we'll have to do it parametrically, because if we give a particular value to this surface, sometimes it might not intersect. What I mean by this is, so we have the point, and I mentioned we could draw a circle, right? And it has to be in relation with the sphere. So the data that we have of the sphere is the radius of the sphere. So if we give radius of the sphere, what happens is you have this goes till the center of the sphere, but then if you have a longitude which is on the side, it won't intersect. So we have to make sure that this one covers the whole sphere. So from a geometry point of view, this is basically the diameter. So if you multiply the radius, then it should always be included within. So you can add a multiplication component here. Add this. And then just make it twice. Now you have a thing which is much bigger. You can use the component curve to surface. Now you get the surface. And what you need to find is the intersection of your other curve to the surface. And then you'll have that point that we are looking for. So we have intersect surface and curve. Exactly. So we have the surface, and the curve is this curve that we have rotated, the final one. Take it, add it. Oh, okay. So now we have the point, and then we can hide all the other things. So let's create a group for these. Latitude. Group this and call it coordinates. If we have any place that we want to try out, we just need to add coordinates here. So this is done. Now we can hide all the I can just test it out. So if we give the 51 and 0, we give say 51. Yeah, and this is somewhere close to London on the map, on the globe. Cool. So that's done. The last part of the script is to set up the sun path. So we're almost there. What we need to do is to set up the sun path. So let's first create that circle, the base, and then we put the block on it, and then we can start creating the sun geometry. So we have the point, we have that location. What we need is to now create a circle. If we create the circle, radius needs to be much bigger. So maybe we can give 100 because we've been giving in hundreds to the planet. Okay. Now what we can see is the plane is taking the XY plane. What we need is to align with this. So for that we need to create a vector, again vector 2 point, which starts from here and then goes through this this point. Center point. And then we have this point. So now we have the vector. And we need to create a plane. So we use the same plane that was created using a normal. So that way you get the exact perpendiculars the way we used to slice this earlier. The origin in this case is this point. This is the origin. This and the axis is we just need to create circle using this as a reference. So now we get it. Yes, so that's the base. We can create a surface. Can apply the green color, something like that. surface. Another thing is to add the building. So we add, say, box center. The origin is this thing that we created. And for this, we could maybe 50 should do. Yeah, that should be fine. Yeah, so that building is also ready. So the two things of the sun path is done. And what we need to do is to create this part, the yellow area. So since we haven't calculated the tilt and the azimuth and all those details, we won't be able to track it along the full path, but we can make assumptions and set up a range where normally the variation happens, and then we can proceed accordingly. So in this case, what we need to create is a sphere around this geolocation. So let's start with the sphere, and we give the radius that is same as the radius that we gave for the base. The origin is this point. And then we'll do something that we did for this one, which is to find two rings. I would say three rings. I'll make a new one. So in this case, what we want is we have this as a base, and then we have the, say, the building block that's here. There is a particular angle that is assumed to be the normal sun path range. And then what we need is two rings, top and bottom. And then we just need to create a surface along this, right? So that's what it is. So if we look at it closely, that's what we can see. And then based on the location of the sun, we create another ring that is visible. So it shows the exact pathway that the sun is taking. Cool. So for that, we need to see if we can make it still visible. So find material and then I'll add opacity to it. What we need to do is something similar to this. So we have to rotate, identify the vector, keeping this as a base, and we have to identify an angle which is somewhere around the range of, let's say, 21, 23. And then we find the same point at the bottom and get the rings. So for that, we need that particular value, which is, let's say, 23. We want minus 23 as well, because we want the ring at the bottom. And then we want a ring at the center. So that would be 0, because this will help us create a nice loft, nice surface, which replicates the sphere as well. Now we need this in the same order. So for that, we can use a list merge. That goes there, and then now we have 3 of them. So these are in degrees. Therefore, we need to convert it into radians. It's the same process that we used here. So we have X, Y, and then we are rotating. So the same way we need Y here. And then we create a line. And this is using line STL. So the vector is this. Point is the center point, which is here. And the length is the radius that we just gave. So that creates 3 lines. As we did earlier, we need to deconstruct the sphere so that we get the surface. So we do the same thing. We deconstruct, and then we extract the surface. Then we add it to the intersections. Surface. So you get these 3 points. What you need to do is to slice it at these points. So currently we have 3 points coming in, and then we need to create the normal plane. So that the plane is what we'll use to create those slices of the sphere. So we need to create a plane using the normal. Pin, edit. And then we bring back our command of solid plane. So we take it from the tools, intersection, solid, using planes. And the solid is our sphere. So we now have those slices. We can now what we need is to loft them together to get that surface. We can hide this. We can hide the surface. We don't need this either. What we need is to loft. So before lofting, a good thing to do will be to flatten. You flatten the curves so that it's all in one path, and then you can loft the surface together. Cool. So now you have the surface, and we can apply some material to this as well. Since it's a sun path, we can give a bit of opacity, maybe 0.5, and then color of sun. Yep, and then we can hide the rest. There's one more thing that we can do, that is to demarcate the sun. Because we know where the sun is, but it'll be good to get the sun here. So if you go back, you can see where the point is. This one. We need to create one. So let's create a new line. So we have line STL. The length is same as the radius of that sphere. We have the point that's starting from the center, just this point. And we need the vector which is the directions. For that we need vector 2 point. First point is the center. The second point is the point of intersection of this line with the center of the sun, because we're tracking the sun right now. So that would be the way from here. Or you could just give it 0, 0 because we have taken that as a point. Okay. And the sun is on the other side, so we can maybe adjust the latitudes a little bit. Yes. Okay. Yes, that's more clearer. You could again do an intersection, which is intersecting the surface and the curve. That this is a curve and the surface is the deconstructed one. So we get the point. Create a small sphere. Here and then apply another material to it. Yes, okay. What do we have now? I think we have it. I think we have all the pieces. One thing you can do is you can do a demo and then check if the things are in place. We have the base dimensions, we have Earth's position, we have the coordinates, we have the select. The day. Yes, and then once we have that set up, all we have to do is minor tweaks here and there, a bit of adjusting the material with the opacity, and then we have a setup that is good enough to then go into detail regarding the concepts of sun path and all that. Okay, I think I took a bit additional time to explain this, but I hope it was clear. All right, that's it then. Thanks a lot, guys. If you have any questions, yeah, please do ask.
Yes, Hafiz, I think it all got covered. We were running short of time although, but I think
Yeah.
we have got covered. And so we have Anwar and Jiyun and yeah, anyone else who has any question? I think Ivan is also there. So you guys have any question, please let us know.
Just one question, maybe for learning as well. Let's say we put something in the configurator mode, open to everyone. Can we download anything apart from a JPG or an OBJ file? Like, for example, if we put this model out where people can get the sun path for any location, what all possibilities do you see that people can download it, usable data to inform their designs?
Well, in this case, probably only OBJ and step would make sense.
Mhm.
What? Then I'll ask the question back. If it wasn't BeeGraphy, like what could be the formats that you would need?
Like, for example, till now, if it is like a Rhino environment, then I have to download a plugin, like a Ladybug or Honeybee or a Climate Studio, and then I perform it. So I'm modeling natively inside Grasshopper or Rhino, and then I download a plugin for that and then do it there. It is similar in Revit that I need to do. If I'm modeling it there, then I download something from that, and then I just put shadow zone and export it as JPGs and then put it in the final presentations or slides. That is a typical workflow followed by everyone at the moment.
Okay. So exporting some sort of screenshots in JPEG or
Yeah,
something. Okay. I think that should be pretty easy to implement. So just use screenshots from the viewport.
Yeah, that would be good.
Okay. Thanks for the feedback, guys. I
Yeah.
think this could be something that we could prioritize.
I think exporting high resolution images, not just for this application, will be good in overall for even if it is just modeling, design modeling, getting an image output. Because the material application without textures is working pretty good. All the reflectivities and stuff can be there. And just another like request, I don't know whether it is possible or not. maybe directly in the configurator mode, we can switch on or off the video or the ground plane, because that is not there. So if something needs to be exported from configurator as an image, then it will be like a floating object, not with a ground plane and a shadow.
Okay, got the point. So the options that could be is when exporting, either change the mode,
Yes,
render it,
exactly.
or
Yeah, you can
shaded.
configure like randomly in the shaded mode, and whenever you are happy with the configuration, just export it as like rendered mode with shadows on and the ground plane on.
Mhm. Okay, got it. We can do that. I think I'll put it on the to-do list.
Yeah, there was another thing that I noticed. I need to check again. It was that when we group objects together, then the function of clicking and it going back or tracking was being lost. So if I have 2 or 3 components and then I group them together, and then when I double click on it, it wasn't taking me to that location. I think I'll need to check that again. I'll add that on our further discussions if that happens again. Like it works when it's not grouped, but when I group it and I double click, it doesn't take me inside the group and show me.
Okay, interesting. Maybe a bug. Thanks for noting.
I think we can look at it later. So if you can forward that issue, Surface.
Yeah.
Learning, I think, is in driving mode. So it's probably vibrating.
My wife is driving on the other passenger seat, but it's shaking.
Yeah.
And also the navigation system is talking.
It's like there's an earthquake there. Yeah.
So I think, Surface, you can share that issue and look at it. So cool. I think we are done here. So we have some replies from Anwar and June. So the topic was very interesting. You can please, yeah. So it will be uploaded on the BeeGraphy YouTube channel, and you can check it over there.
Okay, then if we have no more questions, then we can probably sum it up.
Thanks a lot.
Thank you very much, guys. Thanks everyone who stayed until the very end, and also those who left earlier probably had other things to do. Thank you, guys. It was a very good one. I think each model had its part that could educate others on the tools that could be used, and also the educational part was like interesting that it's not only something that you design to print, but also something that you design to visualize.
Yeah.
Yep.
Then I wish everyone a good weekend. Thank you.
Yeah, we will call this off a session.